Well, in the last video we did something about the cyclic symmetry, and I just wanted to show you how you get automated your outputs of the objective values from the out file. And yeah, I will be talking about a side project of mine in this video about coding, stuff like that. So yeah, feel free to check it out, and yeah, let's jump into it. Now, you saw here that I did some simulations for the symmetry constraints, right? And you see that I had noted this compliance value for each of every simulation. The thing is, how did I get this value? So one way of doing it, amongst others, is to just go in your directory, right? So you have, for example, that one, and you have your simulation results. So I just ordered it like this. You have your cyclic symmetry folder, and then I have 5, 10, and 15% of different simulation types. And there I have changed the U cycle, so the number of cyclic repetitions for the cyclic symmetry constraint, from 1 to 9. So I can see or identify that by just going through the models, and you see 1 to 9. And now to go here and to check, for example, the optimization objective value, which it finally got for cyclic symmetry 9, I would just open the out file, and let's just close the other text files. And you get something like this. And if you just scroll to the bottom, so you see, yeah, the different iterations. You scroll to the bottom, right, like this. And then you go up a little and you see the last iteration. And there you have, for example, the sum of weighted compliance here. Well, I think there is also, yeah, here you get it. You have iteration 74, which is the last one, right? Yes. And then you get objective function, in this case, minimize weighted compliance equals that value. And then you get also a percentage change from the latest iteration to the iteration now. Now this is the value you're looking for. And how to extract that? Yeah, you could go into every directory and every folder, and you just look for the out file, you scroll down, you get that value, transfer it to Excel, whatever. Yeah, you can do that, but it's not really a good idea. Things like that can be automated. And I just made that to a little bit of a thing which I could do, and you could also use. So what I created was a, let me see, wait a second, I have to just go through to it. But what I created was a little tool for it. And I made that into a bigger repository, which I plan to just do a little bit more about it in the future, which is called Hyperworks tools. And I just show that to you on GitHub as well. So you can see here that, yeah, it's pretty in a first rate state. I don't have really readmes right now, but it's just, this thing is working with the objectives, but I plan to do more on that later. So this is the address you can get the files here, and I will just do a proper readme. But just let me walk you through one time here, so you can use it if you want to, and just also give me your ideas what I should maybe also include. So if you just download the code, you get something like this. This is your folder. And you can then look into this task file, because task file is used for my program here to just, yeah, get things easier. That means, well, let me explain that a little. Task file lets you just write down commands and just give shortcuts to them. For example, there are different tasks. For example, here, lint, install, build. So you would have, you would need a task file to be installed on your system. That's the only thing you would require for that. And besides that, maybe Poetry too. Yeah, to just install that. But if you have Poetry installed and task file installed, you can just go quickly and just go like task install. So you just go into the root directory of Hyperworks tools, and then you just enter task install. And what this will do, it will just use Poetry to just install all dependencies. And yeah, that's pretty important for if it grows and has a lot more dependencies, it's easier to just install it with one click and you don't have to fungal around with other projects. So this is a cool solution. So task file, I will just put also a link into the description how to get task file. That's just a binary. You put it in your path value on Windows, and yeah, that's about it. And so you can use task, and you can check if task works if you just enter task and there is not that command task not found. So this is how you check that. So when doing task install, you should have then a fully installed, ready to go program here. And that means you can then do something like task CLI. And this is exactly what is done here. So task CLI, this is short for command line interface. And if you just enter this task CLI, you will get something like this. That means you see commands, and there will be more commands in the future. But for right now, you have just objectives. And if you just want to use that command, there's one little trick. So obviously you would want to just type objectives here, right? But this is wrong in that case because task has its own set of commands, and so you have to make like -- and then you can type the objectives. I cannot type anymore objectives. And then you could give a path, all right? But be aware, this is now a path to simulation models. So alt files are present in that path, which is a must. But now the thing comes with Windows. Well, task does not work really well with backslashes. So you would have to change those to forward slashes. I mean, yeah, it's a little bit tricky, but yeah. If you have done that one time for your path, then you could just do it. Yeah, you could call the command again with just an up arrow. Yeah, and if you run that, you see that you get a just a list of all out files it found in that directory and just the latest and greatest objective value you could achieve. And just to see if it's correct, this was the same folder like the cyclic symmetry file we have opened. Yes, and this 0.275 is exactly that what we have here, 2.75 with the power of -1. So this is an easy way. Now, let me just quickly talk about what I plan to do on this repository in the future. So I would like to have not just post commands, but also pre-commands. And pre-commands, what I just introduced here are the initial TCL scripts which build up a typical small model for you as a quick start to get going. And maybe something like you could specify, I don't know, maybe the Young's module and the Poisson ratio and the number of components, and it will just create your TCL commands for creating exactly that. So there's still much work to be done about this, and I hope that I can make it even easier to use it for you. So it should be sometime in the future. It should be just a simple install command with pip, and you can just access it by going that. But if you just are a little bit more with a affinity to coding and stuff, check it out. If you have any questions regarding the repository or if it does not work, whatever reason, just leave a comment and we will get that working on your computer as well. All right, that's about it. Thanks guys for watching. If you liked the video, please like, subscribe, comment if you have questions, and I will see you in the next video. Bye guys.